Back. Recording got all crazy, so we're continuing on. So, this one's gonna be x is equal to 1. Now for this one, right, in order to solve for the x, add both sides by 1, and x is gonna equal to, or 5x is gonna equal to 1. Divide both sides by 5, and x is gonna equal to 1/5. So, those are your guys' roots. So, x is gonna equal 1, 7, 1, and 1/5. And those are you guys' roots. Okay, so that's number 15. Now we are off to number 16. Okay, so here's number 16 on the homework. Alright, so let's take a look at this. So for number 16, same thing, so we have to find our p's and we gotta find our q's. So here's your guys' p, which is this 5. And here's your guys' q, which is that 3. Now, gotta find our p factors. Which is gonna be plus or minus 1 and 5. And then our q factors, which is gonna be plus or minus 1 and 3. Now we gotta find our p over q. And that's gonna equal plus or minus 1 and 5 all over plus or minus 1 and 3. Alright, so remember, now in order to find our p over q, when we have more than one value in the q, now we have to do every single numerator over every single denominator. So that's going to equal to plus or minus 1, because 1 over 1 is 1. 5 over 1 is going to be 5. And then we're going to do the red over the green now. So 1 over 3 is just 1 over 3. And then 5 over 3 is just going to be 5 over 3. So this is all possible roots. These are all your guys' possible roots. Alright, so now we can do synthetic division. We got 3, negative 10, negative 24, negative 6, and we got 5. Now we gotta guess a root, right? From our possible roots. Let's just guess one. Multiply, add, then multiply, add. So 1 times 3 is 3. Add together, negative 7. Multiply 1 and negative 7 for negative 7. Negative 31. And I'm going to stop because I am noticing that there's no possible way that we're going to get a negative 5 right there. So I'm going to erase this. And just for a reference, I know 1 cannot be a root. Let's try negative 1 though. Negative 1 times 3 is negative 3. Add together, negative 13. Multiply negative 1, negative 13 for 13. Add together for negative 11. Negative 11 times negative 1 is 11. Add together, and look at that. 5 times negative 1 is negative 5. So we found one root. Now I notice that I have 4 coefficients, and that's not a trinomial, so now we're going to do the synthetic division again. So I'm going to write these coefficients down. Now we gotta guess another one. So we got negative 1, that's good. Now we have those fractions. Oh, we also have 5 or negative 5. So I'm gonna put 5. 3. 5 times 3 is 15. We get 2. 2 times 5 is 10. And then we add to get negative 1. And look, we got it. Oh, no, not that. So now what we're gonna do is, now we have a trinomial, so now let's put all this into looking like a polynomial. So opposite of negative 1, x plus 1. Opposite of 5, x minus 5. And now let's put this in a trinomial. Constant, first degree, second degree, so 3x squared plus 2x minus 1. All of that is going to equal to 0. Now let's see if we can factor out this trinomial. So we are going to have 3 times negative 1 for the top, which is negative 3, and we got 2 on the bottom. And I see that 3 times negative 1 will give me negative 3, but when added will give me 2. So notice that our a value is 3, which means we have to do the x method, which is 3x squared. We have to write that first term twice. We got 3x. Remember, you have to add an x to it, right? And negative 1x. Simplify both of these. So 3x could go into top and bottom for this first one. So x over 1. And I see an x in both the top and the bottom. So we're going to get 3x over negative 1. So let's write down the factors. X plus 1. X minus 5, and then x plus 1 coming from right there, and 3x minus 1. All that's equal to 0, and that 3x minus 1 is coming from over there. So let's solve for our zeros. X plus 1 equals 0, x minus 5 equals 0, x plus 1 equals 0, and 3x minus 1 is equal to 0. X is going to equal negative 1 there, x is going to equal 5 there, x is going to equal negative 1 there, and if you guys solve for this one, x is going to equal to 1/3. So, negative 1, 5, negative 1, and 1/3. And there's your guys' answer for number 16 on the homework, I believe. Yeah. Now let's take a look at 17. Now, here are some strategies for when you guys do number 17. Well, I'll get to there soon, but first we gotta still find our P list and Q list, right? We still gotta find our P list and our Q list. So, this one is your P, and this one is your Q. I don't know why it always cancels out, but there's your P, and that one's your Q. Alright, so, your P factors are going to be plus or minus 1 and 12, plus or minus 2 and 6, and plus or minus 3 and 4. And your guys' Q factors are going to be plus or minus 1 and 3. Okay, so P over Q is equal to plus or minus 1, 2, 3, 4, 6, and 12. All over plus or minus 1 and 3. So, remember, I'm going to move it over here. We have to put every single one of these numerators over each denominator. So let's first do all the red numbers over the green. So 1 over 1 is plus or minus 1. 2 over 1, which is just plus or minus 2. 3 over 1, which is plus or minus 3. 4 over 1, plus or minus 4. 6 over 1, plus or minus 6. 12 over 1, plus or minus 12. So that was red over green. Now we gotta do all the red ones over the purple. So 1 over 3 will give us plus or minus 1/3. 2 over 3, which is plus or minus 2/3. Now, 3 over 3, you guys, is plus or minus 1, but we already have a plus or minus 1 in our list. So no need to do that. 4 over 3 is plus or minus 4/3. 6 over 3, well, that's just 2, so we don't have to write that one. And 12 over 3, which is 4, so we don't have to write that one either, because they're already on our list. So here's all of our possible roots. Now, here is a technique that you guys probably have not seen before. And let's look at our original. Okay, so listen carefully. I know that what a root means, you guys, if we substitute the root into the original equation, which is highlighted in purple up there, then the whole thing is going to equal to 0. So I noticed that we got 3x to the third plus 9x squared plus 4x plus 12. Well, they're all positive. So I know that if I substitute 1 in for each x value, that whole equation is not going to equal 0. So for example, right, let's say, so look up top, let's say I said, okay, let's see if 1 is a root. Well, I'm substituting all my 1s into the x's. And you know if it's a root if this whole entire thing becomes 0. But I already know that's going to be 3 plus 9 plus 4 plus 12. And there's no possible way 3 plus 9 plus 4 plus 12 is going to equal to 0. So I already know 1 cannot be a 0. So I could see, like, if I substitute any positive number into x, then the polynomial is not even going to equal 0, right? So, right, if I did 2 to the third, if I substituted 2 into here, I know that whole polynomial is not going to equal to 0. So basically, I know all of the positive values are not going to equal 0. So positive roots are not going to equal to 0. So that automatically eliminates all the positive values. So now I'm just going to check to see, well, that means our roots can only be negative values. So again, that's just one technique for you guys to try out. So I'm going to write down the coefficients, which is 3, 9, 4, and 12. And let's just find our roots from our possible roots list. So I'm going to do -1. 3 times -1, -3. Add, we get 6. 6 times -1 is -6. Add, we get -2. Well, that's not going to cut it. So we know -1 can't be 1 either. Add it on to the ones we cannot try. Alright, so let's try -2. -2 times 3 is -6, which is 3. 3 times -2 is -6, which is -2. And that one's not going to cut it either. So can't be -2. Let's try -3. 3 times -3 is -9, 0. -3 times 0 is 0, 4. 4 times -3 is -12. And look at that, we found a root. So put it into polynomial form because, right, we have a trinomial now. So x plus 3. And then constant, first degree, second degree, so 3x squared. Now this would be 0x, but 0x is just 0, so I don't have to write that one, and then it's just plus 4 is equal to 0. Now we can either factor or use quadratic formula from this step, but I noticed that we only have 2 terms here. So now I could just solve for it. So x plus 3 is going to equal 0, or 3x squared plus 4 is going to equal to 0. Now -4, -4, 3x squared is equal to -4, divide both by 3. X squared is going to equal -4 thirds, and then square root both sides. Now, these homework assignments are asking for real rational roots. When you guys square root that -4 thirds, that's not a real number. That is an imaginary number. So that means we can't use that because that's going to give us an imaginary. It's the homework question asks you for real roots, and imaginary numbers are not real roots. So our only answer is x is equal to -3. Okay. Here's number 18. So, same thing. Find your p-value, or p factors, and your q factors. So, p factors are plus or minus 1, and plus or minus 15, and then plus or minus 3, and plus or minus 5. And your q factors are plus or minus 1 and plus or minus 2. Again, those are all plus or minuses, but if you guys just write it for the first one and just know that it's plus or minus 1 and 2, it should be okay. Alright, our p over q, we have plus or minus 1, 3, 5, and 15. All over plus or minus 1 and 2. Okay, so now we gotta find our p over q. So we're first gonna do red over purple. So plus or minus 1 over 1 is 1, 3 over 1 is 3, 5 over 1 is 5, 15 over 1 is 15. Now we gotta do red over green. 1 over 2 is 1/2, 3 over 2 is 3/2, 5 over 2 is 5/2, and 15 over 2 is 15 over 2. So those are all of our possible roots. Now we gotta go and find it. Now, take a look at the polynomial, right? It's all positives again. And remember, if we substitute a root into that polynomial and we get that whole polynomial becomes a 0, then that's a root. And I can clearly see that if I substitute any positive root into that polynomial, it's not going to equal to 0. So all positive roots you can't do. So now I just have to check my negative ones to find a root. So synthetic division time. We got 2, 9, 19, and 15. And let's just try -1 first. 2, -1 times 2, -2, 7, -7, 12. Okay, that one's not going to work. Can't do -1, so now let's do -3. 2, -3 times 2 is -6, 3, -9, 10. No, that one's not going to work either. -5, 2, -10, -1. That's +5, 24, not going to work either. I think fear is starting to creep around because I think some of you are realizing that all these whole numbers are not flying, and I'm going to stop right there because there's no possible way that's going to reach us to -15. Which means it's fraction time. So let's try -1/2. 2 times -1/2 will give you -1. We add 8. 8 times -1/2 is -4, which is 15, and that's not going to work because that's -1/2 times 15 won't give us -15. So not that one. -3/2. 2 times -3/2 is -3. We get a 6. 6 times -3/2 will give us -9. 10 times -3/2 will give us -15. So x plus 3/2, and then this is a polynomial, right? 2x squared plus 6x plus 10, all is equal to 0. So I'm going to factor out a 2 from this one. X plus 3/2. I'm bringing the 2 on the outside. X squared plus 3x plus 5 equals 0. Let's see if you guys could do the x method, and look at that, we can't do the x method either. So this is the first time you guys are going to do a quadratic formula. A is equal to 1, B is equal to 3, C is equal to 5. And when you guys do your quadratic formula, right, x is going to equal to -b plus or minus square root of b squared minus 4ac all over 2a. X is going to equal to -3 plus or minus 3 squared minus 4 times 1 times 5 all over 2 times 1. And that's going to equal, x is going to equal -3 plus or minus square root of 9 minus 20 over 2. And look on the inside of that radical, you guys. We're going to get x is equal to -3 plus or minus square root of -11 over 2. You cannot have a square root of a -11. That's an imaginary. So that means all of this is not going to give you a real root. So the only thing you have to notice is, well, we only had x plus 3/2, and that equals 0. So then that means x has to equal to -3/2. Last problems are always challenging, but there you guys go on that one, and that should do it for rational roots theorem, okay?